So today we are going to learn the unit circle, radians, and the trigonometric identities, plus a bonus section at the end. So, the unit circle is a circle whose center is the origin point and whose radius is equal to 1. The unit circle is important for trigonometry because, like we took in the previous video, that sine is equal to y, the y coordinate. But why is it equal to the y coordinate? Well, because in the unit circle, the hypotenuse is equal to 1. So, and when you divide anything by 1, so y, that's just equal to y. So sine is equal to y in the unit circle. And the same applies to cosine, just with the x coordinate. So, cosine is the adjacent, which is x, over the hypotenuse, which is 1. So cosine is equal to x. Also, with the r being equal to 1, that means that the circumference is equal to 2 pi. Why? It's because how we get the circumference is 2 times pi times r, which is just 2 pi. So the entire circle is equal to 2 pi. That means 360 degrees is equal to 2 pi. And how we calculate the radian is the length of arc, so how much of the circle we have covered, over the radius, which in our example is 1. Another way to calculate it is x degree over 180 is equal to theta rad over pi. But why is it 180 and not 360? It's because the two cancels each other out. That's why in the rule is 180. This is used to determine how much of the circle you have covered. So how we calculate is theta rad is equal to x degree over 180 times pi, which, let me give you an example. So 90 times over 180 is equal to half times pi, which is equivalent to 2 over pi. Now, also in the previous video, we took that sine 90 minus theta is equal to cosine theta. Because look, this angle, the side opposite to it, is the same as the side that's opposite to this angle. And these two angles are complementary because right angle. And also sine 90 plus theta is also equal to cosine theta. But sine 180 minus theta is equal to sine theta. Why is that? Well, because when you have the angle 180 or 360, it stays the same, it doesn't flip. But we still need to be careful because look, sine 180 plus theta is equal to negative sine theta. That's the reason. Why is it negative? Well, it's because its sign is not positive in the third quadrant. That's what we have explained in the asterisk rule in the previous video for. So when you have 90 or 270, it flips. And also, why is cosine here negative? It's because sine is negative in the third quadrant and it flips. Because we are using 270. But what flips into what? So here we see that sine flips into cosine, and sec flips to cosec, and tan flips to cotan. That's the reason they are also named like that. Sine, cosine, sec, cosec, and tan, cotan. And also the opposite is true. Cosine turns into sine, and cosec turns into sec, and cotan turns into cotan when you have 270 or 90. Okay, now we get trigonometric identities. First off, we have sine power 2 theta plus cosine power 2 theta is equal to 1, which also means that 1 minus cosine theta power 2 is equal to sine theta power 2, and 1 minus theta power 2 is equal to cosine theta power 2. Now we go to the next identity. 1 plus cotan power 2 is equal to cosec power 2, which also means cosec power 2 minus cotan power 2 is equal to 1. But when you flip them, so cotan power 2 minus cosec power 2 is equal to negative 1. Now the last identity we have, tan power 2 plus 1, which is equal to sec power 2. Then which also means sec power 2 is minus 10 power 2 is equal to 1. And 10 power 2 minus sec power 2, which is equal to negative 1. Also, there's a trick I've gotten an exam before. Sine power 2, sine minus 1 times sine plus 1, which is just the difference between two squares. Sorry, I messed up. I meant 1 minus sine times 1 plus sine. That's the difference between two squares, which means 1 minus sine power 2. So all of this is equal to cosine power 2. Now let's go to the bonus part. So we know that sine is equal to y and cosine is equal to x. And so sine power 2 is equal to y power 2, which is equal to the opposite side if we are using this angle. And cosine power 2 is equal to x power 2, which is equal to the adjacent side power 2. But wait a minute, this looks like the Pythagorean theorem. In our example we are using the unit circle, so the hypotenuse is equal to 1. So sine power 2 plus cosine power 2 is equal to 1 because of the Pythagorean theorem. Because look, a squared plus b squared equals c squared. And in our example, c is equal to 1, a is equal to sine, and b is equal to cosine. That's the reason why it's like that. Now, you have 1 plus cosine power 2 equal cosec. But why is that? Well, 1 is equal to sine power 2 over sine power 2, which is just 1, equal to 1. And cosine power 2 is cosine power 2 because adjacent over opposite, cosine power 2 and sine power 2. And since they have the same denominator, it's also all of this is equal to sine power 2. Sine power 2 is down and up is sine power 2 plus cosine power 2, which we said previously is equal to 1. So that means that all of this is just equal to 1 over sine, which is equal to cosec power 2. We discussed that in the previous video. Same with this one, with this trigonometric identity. Let me just get a new paper to write it down. So 10 is equal to opposite over adjacent, which is also equal to sine over cosine, and 1 is also equal to cosine over cosine, because when you divide something by itself it's just equal to 1 always. So cosine power 2 over cosine power 2, which is equal to 1, we add that to 10, which is sine power 2 over cosine power 2, which is equal to 1. But why 1? Okay, it's the same denominator, so we just get it down. Cosine power 2, we take it from here, plus sine power 2, which is also sorry, this is completely wrong. Which is when we said here equals to 1. So all of this is 1 over cosine power 2 theta, which is sec. Well, that's what we have for today. As always, I'm open to suggestions, and I'm of course not only doing math, so I'm also open to non-math suggestions. I'm here to help us learn together. Bye, and see you next time.